Today we're going to start section 3.3, proving lines are parallel. Last section we said if two lines are parallel, then corresponding angles are congruent, alternate exterior angles are congruent, alternate interior angles are congruent, and consecutive interior angles are supplementary. So in this section we're just going to work backwards. So in this case we're going to talk about the converse. Right? And remember from way back in the beginning of the year, converse, right? If we have a conditional statement, an if-then statement, the converse, we're just taking the hypothesis and the conclusion and we're switching them. So in this section, if our corresponding angles are congruent, if our alternate exterior angles are congruent, if our alternate interior angles are congruent, and if our consecutive interior angles are supplementary, then we know our lines are parallel. So instead of proving that angles are congruent or supplementary, in this case, we're going to be proving that our lines are parallel. So first we have our corresponding angles converse. If two lines cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So we know here that angle 2 and angle 6 are corresponding angles. So if angle 2 is congruent to angle 6, so if our corresponding angles are congruent, then J is parallel to K. So if we know that angle 2 and angle 6 are congruent, then we can say line J is parallel to line K. Because our corresponding angles are congruent, our lines are parallel. Next, we have the alternate exterior angles converse. If two lines are cut by a transversal, so the alternate exterior angles are congruent, then the two lines are parallel. So here we know angles 1 and angle 8 are alternate exterior angles. So if angle 1 is congruent to angle 8, if our alternate exterior angles are congruent, then J is parallel to K. So if our alternate exterior angles are congruent, we know that line J is parallel to line K. Next, we have alternate interior angles converse. If two lines are cut by a transversal, so the alternate interior angles are congruent, then the two lines are parallel. So here we have angle 3 and angle 6. We know these are alternate interior angles. So if angle 3 is congruent to angle 6. So if our alternate interior angles are congruent, then J is parallel to K. So when we have alternate interior angles that are congruent, we know our lines are parallel. J is parallel to K. Lastly, we have our consecutive interior angles converse. If two lines are cut by a transversal so that the consecutive interior angles are supplementary, right? They add up to 180. Then the two lines are parallel. So here we know that angle 4 and angle 6 are consecutive interior angles. So if the measure of angle 4 plus the measure of angle 6 is equal to 180 degrees, then we can say J is parallel to K. So let's say angle 4 is 100 degrees and angle 6 is 80 degrees. 100 plus 80 is 180. So we know angles 4 and 6 are supplementary. We can then say line J is parallel to line K. So for the first example, we want to find the value of x that makes line M parallel to line N. So here we have two angles that are labeled 3x plus 5 and 65 degrees. These two angles we know are corresponding angles. They have the same position. And we know corresponding angles must be congruent for our lines to be parallel. So we have to find a value of x that makes these angles congruent or have the same measure. So here we're just going to set our expressions equal. 3x plus 5 is equal to 65. I'm going to subtract 5 from both sides. 3x is equal to 60. And I'm going to divide by 3. We get x is equal to 20. So when x is equal to 20, if we plug that into our expression up here, 3 times 20 plus 5, we're going to get 60 plus 5, which is 65. So now our two angles, our two corresponding angles, are congruent. So when x is 20, we know our corresponding angles are congruent, so our lines must be parallel. For the next one, is there enough information in the diagram to conclude that J is parallel to K? So in this case, if we look at the two angles we're given, 75 degrees and 105 degrees, these two angles don't specifically have an angle pair that we've talked about, but we can find some other angles based on this that will help us out. So what I'm going to do is, I'm going to look at the 105 degree angle. I know that this angle with a question mark and the 105 degree angle are a linear pair. They form a linear pair, so they must be supplementary. They must add up to 180 degrees. So to find my question mark, I'm going to do 180 minus 105. And in this case, I'm going to get 75 degrees. So now I know that my question mark is 75 degrees. So if I look at now the two 75 degree angles, again, I know these angles are corresponding, and corresponding angles must be congruent in order for our lines to be parallel. In this case, these corresponding angles are congruent, so we know our lines are parallel. And the reason for this would be the corresponding angles converse. So yes, J is parallel to K because of our corresponding angles converse. Our corresponding angles are congruent, so we know our lines are parallel. I want you to pause the video and try number 3 on your own. So for number 1, we want to prove that lines, we want to see if we can prove that lines A and B are parallel, and then explain why or why not. So in this case here, the two angles that they give us, our two congruent angles here, are alternate exterior angles. And because our alternate exterior angles are congruent, we can say our lines are parallel. And the reasoning for this is the alternate exterior angles converse. So yes, M is parallel to N. For the next one, we have angles 1 and angle 2 are in the same position, so these are corresponding angles. And we know that corresponding angles must be congruent. But in our problem here, it says that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. So that information doesn't really help us. That doesn't tell us that angle 1 is congruent to angle 2. That tells us that angle 1 and angle 2 are supplementary. And remember, our congruent angles our corresponding angles must be congruent. So in this case, no, we don't have enough information. The last one here, we have two angles that are marked congruent. These two angles are alternate interior angles. And we know that alternate interior angles must be congruent for our lines to be parallel. In this case, they are. So we can say, yes, M is parallel to N because of the alternate interior angles converse. So remember, our reason for lines being parallel is always going to be the converse, not the theorem. The theorem proves that the angles are either congruent or supplementary. The converse proves that the lines are parallel. The transitive property of parallel lines: if two lines are parallel to the same line, then they are parallel to each other. So if P is parallel to Q and P is parallel to R, then we can say R is parallel to Q. So then all three are parallel to each other. Next, we want to find the value of x that makes M parallel to N. So in this case here, we have corresponding angles again. So it's always important to identify the angle pair that we're given. Corresponding angles must be congruent. So we're just going to do 2x plus 15 is equal to 135. Subtract 15 from both sides. We get 2x is equal to 120. Then we're going to divide by 2. We get x is equal to 60. So when x is equal to 60, right, if we were to plug that in here, 2 times 60 plus 15, we get 120 plus 15, which is equal to 135. So when x is 60, both angles measure 135, so our corresponding angles are congruent. Pause the video and try number 2 on your own. So here we have consecutive interior angles. And we know that these must be supplementary. They must add up to 180. So we're going to do 150 plus 3x minus 15 is equal to 180. We're going to combine like terms. So 150 minus 15 is 135. We're going to subtract 135 from both sides. So we have 3x is equal to 45. And then we're just going to divide by 3. X is 15. So when x is 15, we know our two angles are supplementary. They add up to 180. So we know M is parallel to N. Pause the video and try the next one on your own. So here again, we have consecutive interior angles. We know that they must be supplementary. So we're going to do 2x plus x is equal to 180. So we have 3x equals 180. We're going to divide by 3. So x equals 60. So when x equals 60, we know our consecutive interior angles are supplementary. Last one, complete the steps to determine whether DB is parallel to HF. So first we want to find the measure of angle DCG and the measure of angle CGH. The measure of angle DCG is 38 plus 77, which is 115 degrees. And the measure of angle CGH is 180 minus 15, 115, which is 65 degrees. And the relationship between these two angles is that they are consecutive interior angles. Lastly, we can say line DB is parallel to line FH because the consecutive interior angles are supplementary. So the consecutive interior angles converse.